Hi guys, so let's see the question number 8 of ISI UGB 2025. So in this we have given that for n greater than equal to 2 and let a1 less than equal to a2 up to less than equal to an be positive integers such that summation of ai is equal to product of ai. In sum of the integers is equal to the product of integers. Then we have to prove that summation of ai is less than equal to 2n and determine when equality hold. So first of all, we will try to identify can we solve this or can we find out the integer which satisfy this equation. So again, one thing that we can say that the right hand side is most of the time is greater than the left hand side, isn't it? Most of the time the product of integer is greater than equal to the sum of integers, right? Same integers we can say. So how to make them equal? Let's see, if I say I have a 2 into 3, then 2 plus 3 is 5, right? It is not 6. But if I add 1 in that, then they are equal. And in fact, 1 will not affect the product. So we can say we can write any product as a sum, right? And whatever the gap between the product and the sum, we can fill that with the by using ones. Let's say if we pick a one more example, let's say 3 into 2 into 2, it is 12. So I can say 3 plus 2 plus 2, it is 7. So remaining number should be 1, isn't it? And here if I use 1, that will not affect our number, our product, right? So means we can always find a solution, isn't it? We can always write a product of integers as a sum, right? In this way, by using extra ones. So that is definitely we can do in any case. Now, what we have to prove that if we have a n positive integer which follow this property, no? If we have n positive integers so that summation is equal to product, then the summation is less than equal to 2n. Now if I consider our this observation a general form, let's say if I have a r numbers, if I have r positive integers, okay, and I'm saying that here ai is greater than equal to, okay, we are not using ones here because one we can multiply at the end. So that is equal to their sum plus some ones are there, maybe, maybe not, but if there is any difference then definitely there should be some ones. And can we say that the product of integer never be less than the sum of integers, isn't it? The product of integer is always greater than sum of the corresponding integers provided they are greater than equal to 2. I think that we can definitely say, isn't it? Product of integer is greater than equal to their sum. Or even we can prove that if I say, let's prove it, that summation of ai is never greater than product of ai. And we also know that they follow this property that a1 less than equal to a2 up to less than equal to an, right? So summation of ai, which is a1 up to an, can I say it is less than equal to an plus an up to an? Because the as a1 is less than equal to an, a2 is less than equal to an, so this is their maximum value, right? And if we talk about the product, what is the product of ai? It is a1 a2 up to an, so which is greater than equal to, as ai is greater than equal to 2, so I can say 2 into 2 up to an. So an we keep as it, and before that up to an minus 1 I got 2. So it is 2 power n minus 1 an, isn't it? So it is greater than or equal to 2 power n minus 1 an. So the greatest value of summation of ai is this. So if we prove that this greatest value is less than their minimum value, means the greatest value is not greater than their minimum value, then we can prove this easily. Now, summation of ai is not greater than product of ai. So let's see. Can we say NaN? Okay, let's do this with a contradiction. If we are assuming this is greater than 2 per n minus 1 an, okay, we are assuming that let it is true. Let the minimum greatest value of this is greater than the minimum value of a right hand side. So it means we need n is greater than 2 per n minus 1. Is it possible, guys? If I use n is 2, it they are equal for n is equal to 2, and if I put any other value 3, 4, 5 and so on, then you can see that right hand side is greater than the left hand side. So summation is never greater than the product, right? So that we can definitely say they can be equal, or either the product is greater than the sum. Okay, guys. So that is definitely true. Now if I say I have a product a1 a2 up to ar, where ai is greater than or equal to 2, right? So and the corresponding sum is a1 up to ar, or I can say I can represent in this form, and this is summation of ai. So this value is greater than or equal to this. So if I subtract them, it may be 0 or more than 0. Let's say k. So this gap, this value, the gap k is filled by the ones, isn't it? Because these number of ones we use to equate the product of ai, summation of ai plus 1. So what are the number of ones here? That is product of ai minus summation of ai, where I is 1 to r, right? So number of ones are these much. Product of ai minus summation of ai, I is 1 to r. So we pick r numbers. So a1, a2, ar this side, and summation of a1, a2, ar plus 1, 1. Now, if we see the number of terms, because we have to see the number of integers, number of terms that are participating in it. Because a1, a2, ar, we are using that as some numbers, but in actual, how many numbers we are using? Because the remaining numbers are 1, 1. So actual number of numbers in our example, or in this case, is, as these are r numbers, a1, a2, ar, and the remaining numbers are ones. And how many ones are there? This much. So I is 1 to r. So that is our n. So number of terms in this form is r, if we are using r positive integers which are greater than or equal to 2, r plus product of those ai minus summation of ai, right? So these are the number of terms. Now the next thing that we can try to prove, that can n take any value, right? Because we have to say that for any integer n which is greater than or equal to 2, so first we have to prove this, that n can take any value that is greater than or equal to 2, right? So as we have n is equal to r plus product of ai minus summation of ai. If I use r is equal to 2, because we cannot use r is equal to 1. So r is equal to 1 means we're saying that a1 is equal to a1 which is a single number. Na? In this case n is 1 in fact. If we are using r is equal to 1, then a1 is equal to a1, that is a single number, and we are saying n is greater than equal to 2. So let's say if we pick a case r is equal to 2, what you will get? N is equal to 2 plus a1 a2 minus a1 plus a2, that we can further write in this form, a1 minus 1 a2 minus 1 plus 1, right? Now again further, as just we want to prove that n can take any value, let's say a1 is 2, then what you will get? 1 plus a2 minus 1, or n is equal to a2. Now what is the condition on a2? A2 is greater than equal to 2, that is the only condition, guys. So I can say that as n is equal to a2, so n can take any integer value. So first we prove that for any n we have a solution, means it is we have a solution for 3 positive integers, 4 positive integers, any n positive integers. Now let's see what we have to do. We have to prove that summation of ai is less than equal to 2n, right? So now let's see what is our n. N is r plus product of ai, I is 1 to r, minus summation of ai, I is 1 to r, right? So that is our n basically, no? If we are saying that we have a r positive integers which are greater than equal to 2 and the remaining are 1, so this is the number of terms or number of positive integers we are using there, right? So what this condition implies? This condition implies that summation of ai is less than equal to twice of n, and n is this. Now here summation of I means it is I is 1 to n. Now, all numbers we are talking about, the sum of all numbers. So that sum of all numbers, we can say it is equal to the product of numbers. No? As we have sum of number is basically 1, like if we have a summation I is equal to 1 to n, which is product of I is equal to 1 to n, and we are saying that some of them are ones, right? That we write here. So the left hand side is something like we have some ones and we have a r numbers which are not ones, right? So that is the thing. From a1 to an, some are the ones and the remaining are greater than equal to 2. So let's say those are r numbers a1 a2 ar, that we assume here also. So it is equal to a1 a2 up to ar because the remaining product is 1. So either you can write this as a product of a1 a2 up to ar, no? This summation ai, which is I is equal to 1 to n, can be write as a product of ai where I is 1 to r less than equal to 2r, plus this product is also from I is equal to 1 to r. So which ultimately lead us to prove that product of ai I is equal to 1 to r is greater than equal to twice of summation of ai minus twice of r, right? So that we have to ultimately prove. Okay, and we also know that r is greater than equal to 2, that we already see that r equal to 1 cannot work. So we have r is greater than equal to 2, so we have to prove this is true for r greater than equal to 2. Now again we can use the same process, that the minimum value of a right hand side and the maximum value of a left hand side. The minimum value of a left hand side, it is basically a1 up to ar, that is greater than equal to, if I put every number as 2, because all are greater than equal to 2 except the last number, so it becomes 2 power r minus 1 ar, right? So this is the minimum value of the left hand side. If we see the right hand side, what is the maximum value of a right hand side? So we have summation of ai, which is a1 a2 up to ar, so all are less than equal to ar, so I can say summation of 2 times summation of ai minus 2r is less than equal to 2 times r ar minus 2r, isn't it? Because ai from r is equal to 1, ai is equal to 1 to r, there are r terms and all are less than equal to ar, so its maximum value is this. So now we try to find out the r for which the maximum value of this is less than the minimum value of the left hand side. So 2 power r minus 1 ar, or even we have to prove that, we have to prove that this value is greater than this, or if if we somehow prove that the minimum value of this is greater than the maximum value of a right hand side, then we proved it, right? Even we have a equality sign also, we have a equality sign also, so we can keep an equality also, that if we prove that the minimum value of the right hand side is greater than equal to the minimum value of, sorry, maximum value of a right hand side, minimum value of left hand side is greater than equal to the maximum value of right hand side, so that we ultimately want to prove. So this is, if I say greater than equal to the maximum value, so that is, you can take 2 common, so it is 2 power r minus 2 ar is greater than equal to r times ar minus 1. Now r times ar minus 1 is less than r times ar, or even we can say that this value 2 power r minus 2 ar is greater than 2 power r minus 2 ar minus 1. Okay, so let's not do that. Okay, we have to compare this one. 2 power r minus 2 ar is greater than r times ar minus 1, right? So if you compare ar and ar minus 1, ar is greater than ar minus 1, that is definitely true. Now 2 power r minus 2 and r, 2 power r minus 2, is it greater than equal to r, guys? So this is true when r is greater than equal to 4. This is true when r is greater than equal to 4. So I can say that this inequality is satisfied when r is greater than equal to 4. Means summation of ai is less than equal to 2n. That leads us to this condition, that if r is greater than equal to 4, then this inequality is proved. But what about r is equal to 2 and 3? We have to, as we have to say that it is always true, so we have to prove it for r is equal to 2 and 3 also. So if we take a case of r is equal to 2, in case of r is equal to 2, we have, means two numbers we have, a1 a2. So if r is equal to 2 is there, and where is our n? N is this 2 plus a1 a2 minus a1 plus a2, which is further we write it in this form, right? And we want to prove that summation of ai means a1 plus a2, We are taking r is equal to first, that is a1 a2. If we are where two numbers greater than equal to 2, in that case we have n is this, that is okay. And if we have to prove this form, that summation of ai less than equal to 2n, which is ultimately leads us to which form, uh, this form, na? Product of ai greater than equal to twice of summation of ai minus 2r. So we can pick from here. So if I say this is equation number 1, so from 1 I can say, if I using a1 and a2, a1 a2 we have to prove is greater than equal to twice of a1 plus a2 minus 4, right? Or I can take twice of a1 plus a2 this side, it becomes a1 minus 2 a2 minus 2 is greater than equal to 0. I think that is always true, because a1 a2 are greater than equal to 2, so this is always true. So again it is proved for r is equal to 2 that it is always true. Then we have a last thing is r is equal to 3. So in r is equal to 3 we have a a1 a2 a3 is greater than equal to twice of a1 plus a2 plus a3 minus 2r, that is 6. So again you can see the sum is left hand side minimum value is 8, and correspondingly the right hand side value, when we put a1 a2 a3 is 2, all of them is 2, it is 6. 2 2 4 2 6 2 is 12 minus 6 is 6. So even if we pick a minimum value of a1 a2 a3 is 2 2 2, the left hand side is great 8 and the right hand side is 6. So again that is followed, right? So even if we go for a higher values of a1 a2 a3, means if I pick any one of them is 2 or 3, then definitely the left hand side will become more greater than the right hand side, right? So clearly for a1 a2 a3 greater than equal to, this is also true. Now we proved that summation of ai is less than equal to 2n. The last part is when determine equality hold. When is the equality hold? So to find the equality, so we what we can do, let's say we have a summation, so we have a this form, summation of product of ai is greater than equal to twice of summation of ai minus 2r. So I can start from here by using equality. At that point a1 a2 ar is equal to twice of summation minus 2r, right? So if I use r is equal to 2, so just to simplify the things, if we use r is equal to 2, I can say a1 a2 is equal to twice of a1 plus a2 minus 4. It's right here. So if I say a1 a2, if I use r is equal to 2, in that case we get that a1 a2 is equal to twice of a1 plus a2 minus 4. So you get a1 minus 2, a2 minus 2 is 0. So it means either one of them is 0. So if I keep a1 is 2, because this is the minimum number, no? A1 is less than equal to a2, and a2 minus 2 I can give any number k, right? Which k is any natural number, or even 2 also. K is greater than equal to 0, we can say, and n is a whole number. K is a whole number. So a1 is 2, and we can say a2 is 2 plus k. So I think that can justify our equality, that if we have two numbers, non-zero numbers, 2 and 2 plus k, and the remaining numbers definitely be 1, in that case you will always get a equality. We can see the we can prove it, that if we have a two numbers 2 and 2 plus k, what is their product? 4 plus 2k. Now if we use that product of numbers is equal to sum of numbers, so that is 4 plus k. So remaining numbers should be ones, no? Because this one is less than this value, 2 into 2 plus k. So 4 plus k is already there, so total value is 4 plus 2k, so 4 plus k. So remaining values we get from the ones. So how many ones we have? K ones here. If we have a k ones, then what is n then? N is k, that's the number of ones, plus 2, because we use two numbers greater than equal to and the remaining are the ones. So number of ones are k and the other numbers are 2. So n is k plus 2. So we have to say that the sum of numbers is equal to, or even the product of numbers, because sum is equal to product. So product of number is equal to 2n. So what is the product of numbers? 4 plus 2k. And what is the sum of what is 2n? 2n is also 2k plus 4. Right? So equality hold in this way, or I can simplify it in terms of n also. Like we have n is equal to k plus 2, right? So you can say that k is equal to n minus 2. Means if you want to write the numbers in terms of n, so you have a k is n minus 2 and k plus 2 is n. So ultimately, and the number of ones are k, which are n minus 2. So I can say n minus 2 ones, and another number is n minus 2, and the last number is n. So these are, if we have these numbers, n minus 2 ones, one number is n minus 2 and another is n, then we have a equalities hold. So that is the question number 8, guys.